Good day, learners. This time you are now ready to solve projectile motion. Let's begin with question number 1. A boy is disappointed because he was turned down or bested by the girl she was courting. He could not help himself to cry on a cliff while holding the teddy bear, supposedly a gift to his beloved girl. Out of anger, he thrown the teddy bear horizontally at 7.5 meter per second from a cliff. That is 64.5 meter high. He regrets on throwing the teddy bear and wants it back. Question letter A. How long before the teddy bear touched the ground? Question letter B. How far from the base of the cliff does the teddy bear land? Please use Gressa. To begin, let's have the given. Always remember, it was explained on the previous video that we need to consider the x-axis and y-axis givens separately. With that, we have here 7.5 meter per second as the teddy bear was thrown horizontally. Therefore, the velocity sub x, or the velocity in x-axis, is 7.5 meter per second. Now, also, it was said that the cliff is 64.5 meter high. Therefore, the displacement is 64.5 meter. Now, since the teddy bear is thrown horizontally, its initial velocity in y-axis is 0 meter per second. And the gravity should be considered as the acceleration is 99.8 meter per second squared down. Now, as you have seen and noticed, there is a free body diagram on the right side of this particular slide. Now, this free body diagram would help you to understand more about the problem by giving visuals in figure and drawing it, enable for you to understand the given and the required. Speaking of the required, we have here the required in letter A and letter B. Letter A says, how long before the teddy bear touched the ground? Since we're talking about how long, it pertains to time. And since time is dependent or independent in both x and y axis, well, we need to put there t for each axis. Now we have here how far from the base of the cliff does the teddy bear land. It talks about the point of where the teddy bear landed from the base of the cliff. Therefore, that is a displacement in x-axis. So those are the required. Now let's talk about the equation. The equation should be the equation should consider the variables that are listed on the pool of equations. Now we have here for the x-axis, d sub x is equivalent to v sub x multiplied to t. Now you have known that we are trying to look for the displacement in x-axis, and the velocity in x-axis was given. However, the time is not given, but don't worry because the time can be shown through the equation in y-axis givens. Now we have here the equation y-axis, which is d sub y is equivalent to v sub oy, or the initial velocity in y-axis multiplied to time plus 1 half multiplied to the acceleration of gravity multiplied to time squared. Now, always remember that not all of the variables are needed or will become very beneficial and able for us to solve a particular problem. With that so, derivation is very important. So we're just trying to look for the time of it. Now let us copy the equation given. Then let us try to substitute the values for each variable. Now we have here initial velocity in y-axis is 0 meter per second, as we have discussed earlier, multiplied to time plus 1 half multiplied to acceleration and gravity multiplied to time squared. Now always remember that any value multiplied to 0 will be cancelled, or it will become 0. With that so, we have just 1 half multiplied to acceleration of gravity multiplied to time squared. Now, we just need again to get the time, or the variable of time. So we need to manipulate the data or manipulate the equation, giving us t squared is equivalent to 2d sub y over g. Now we just need to eradicate the squared for time, and to do that one, we just need to have the square root of it, giving us a final equation of t is equivalent to the square root of t d sub y over g. Now, can we solve this time? Of course, because we have now the final equations as being derived. Now, for the solution in letter A, you just need to copy the equation that we have came up and substitute its value. So we have there 2 and 64.5 meter, which is the displacement in y-axis, over 9.8 meter per second squared, which is actually the acceleration of gravity value. Now we have here 2 multiplied to 64.5 meter would give you 129 meter over 9.8 meter per second. And you just need to do the operations, giving us 13.16326531 second. Do not forget that we have canceled out meter because of the operation given. And the unit there is only second. Now, is that the final answer? No, because we need to get the square root of it. And getting the square root of it will give you 3.628121457 seconds, or considering the number of significant figures, we have there 3.6 second. So we have here our answer for letter A. Now let's move on with letter B. How far from the base of the cliff does the teddy bear land? So we have there our equation earlier that d sub x is equivalent to v sub x multiplied to time. We just need to substitute every value for each variable. So we have known that the acceleration in x-axis, the velocity in x-axis is 7.50 meter per second, and we got the answer for time earlier, which is 3.6 second, giving us the value of the displacement, 27 meter. And do not forget to express your answer again. How long before the teddy bear touched the ground? That would be 3.6 seconds. And how far is the teddy bear from the base? That's 27 meter. Congratulations, you got it right. I believe that you would like to solve one more for the projectile motion. Now let's have question number 2. Let's have this word problem. Are you a fan of soccer? This is for you. Today is the final tournament for the FIFA World Cup. The game is very intense as we are at the last 2 seconds of the game. The Portugal nation football team needs to score at least one more point to beat the opposing team. The sports star Cristiano Ronaldo, a prominent Portuguese footballer, eagerly fired the ball from the ground at 100 meter per second at an angle of 30 degrees with the horizontal. Can Cristiano hit a score if the goal net is 180 meters away? Question letter A. Calculate the horizontal and vertical components of the initial velocity. Question letter B. After 2.0 seconds, how far has the object traveled in the horizontal direction? Question letter C. How high is the object at this point? Now again, let us use Gressa. Let's directly use the given here. Now the given should be separated in x-axis and y-axis as you have known. So we have there the given, which is 100 meter per second. That is most probably in x-axis. We have there the 30-degree angle, which is on the x-axis because we're talking about the horizontal motion of it as well. And the time is 2.0 second because that's after 2.0 second. And for the y, we only have their time that's on 2.0 second as given. Now, let us know what is the required. There are 3 questions that are being asked. Actually, it's 4, but we will just compute the 3 of it. Now we have here the calculation of horizontal and vertical components of the initial velocity. Therefore, we're trying to get the initial velocity in x-axis and in y-axis as being required. For letter B, after 2 seconds, how far has the object traveled in horizontal direction? And since it talks about horizontal direction, we have their displacement in letter X. And how high is the object at this point? Since we're talking about the vertical displacement of the object, we have there the displacement in y, giving us four required variables. All right, so now let us try to have the equation of it. We need to consider what are the equations that gives us the variable on the given. So we have identified here that v sub x is equivalent to v in initial velocity in x cosine theta could help us as the angle and also the velocity, initial velocity, or the velocity in x-axis is given. And also, we need to have the equation of d sub x is equivalent to v sub x multiplied to t, as displacement is being asked. Now, in y-axis, we have here v sub y is equivalent to initial velocity in y-axis multiplied to sine theta, and another equation, you got it there. Now, let's try to solve each item or each letter. Let's have letter A. We need to get and calculate the horizontal and the vertical components of the initial velocity. So let's have the x component first, or the initial velocity in the horizontal component in letter x first. So we have there initial velocity multiplied to cosine theta. We have known that the initial velocity is 100 meter per second, and cosine and the angle over there is 30 degrees. So you just need to multiply the values of it, giving you 86.0 as 86.60254,038 meter per second, or that's simply 87 meter per second, considering the smallest significant figure. Now we have there the y-axis velocity that's equivalent to initial velocity in y-axis sine theta. So you just need to substitute the value of it. You have known that it's 100 meter per second still. And we could say that the angle is 30 degrees as given, giving us 50 meter per second. And we have there our horizontal and vertical components for the initial velocity. So that's it. Congratulations. Now let us move on to letter B. After 2 seconds, how far has the object traveled in the horizontal direction? So let us see how far it is. Since we're talking about how far, it will talk about the displacement in x-axis, giving us here displacement in x-axis is equal to velocity in x-axis multiplied to time. Now we need to substitute each value. So we have there 87 meter per second multiplied to 2 seconds. And we need to cancel out the units of seconds, only giving us the unit of meter. And we have there 174 for the displacement in x-axis. So that's it for letter B. Congratulations. Now let us have letter C. The horizontal, or the how high is the object at this point? So we need to have the equation d sub y is equivalent to initial velocity in y-axis multiplied to time plus 1/2 multiplied to the acceleration of gravity multiplied to time squared. So you just need to substitute each value for each variable, giving you 50 meter per second multiplied to 2.0 seconds plus 1/2 multiplied to 9.8 meter per second squared multiplied to 2.0 second squared. Now you just need to do the operations, and once you have did it, we have there 100 meter plus 1/2 multiplied to 9.8 meter per second squared multiplied to 4 seconds squared. And again, do the operations considering the PM DAS, and we have there 39.2 meter considering it, and giving us d sub y is equivalent to 100 meter plus 1/2 multiplied to 39.2 meter. Now, again, you need to do the operations, giving us here d sub y is equivalent to 100 meter plus 19.6 meter. And again, do the operation, just add it up or sum it up, giving you d sub y is equivalent to 119.6 meter, or considering the number of significant figures, we have there 120 meter for the displacement in y-axis. Now, we have there our final answers. So for letter A, that is 87 meter per second for velocity of x-axis, and for the velocity in y-axis, that's 50 meter per second. For letter B, the displacement in x-axis, that's 174 meter. I just want you to remember that one again because we will be needing that one to answer the initial question. Can Cristiano hit a score if the goal net is 180 meters away? So remember letter B over there. Now we have there letter C, d sub y is equivalent to 120 meter, which we have solved earlier. Now let us answer the initial question. Can Cristiano hit a score if the goal net is 180 meters away? The answer is no, because at the point of 2 seconds, you will just have 174 meter from the initial placement of the ball. Therefore, it does not meet the 100 meters away displacement. So they could not have the score. Sorry to hear that one. Now, this time, I just want you to try something at home. I'd like you to try this question. During a war between the English countries, a cannon with muzzle speed of 1,000 meter per second fired a cannonball off the edge of the castle's wall. Find the cannonball's position R as shown on the free body diagram and the velocity after 35.0 seconds. Kindly use Gressa. You will be solving this one in your respective synchronous classes. Thank you very much for listening. Hope to see you again next time. Enjoy solving. Have a great day.